place in one step or in a number of steps. What it means? It means that the amount of heat evolved or absorbed in a chemical reaction depends only upon the enthalpy of initial reactants and the final products, irrespective of the path or the manner by which the change has been taken place. So, in other words, you can say that the standard reaction enthalpy is the sum of the standard enthalpies of the reactions into which the overall reaction may be divided at the same temperature split up. Okay, so this is a consistent with the fact that enthalpy is a state function. We have already studied it that enthalpy is a state function. So this law also, verify that. So what we can say here that suppose we have to reach here at point B, and our initial point is A and the final destination is going to be B. Now, whether we choose this path directly from A to B or we choose this path from A to C and then C to B, the enthalpy will remain same. What it means? It means if from A to B the enthalpy is delta H, and from A to C the enthalpy is delta H1, and C to B the enthalpy changes delta H2, then the total enthalpy change of the reaction will be, yani delta H will be delta H1 plus delta H2. So delta H will remain same whether you directly go from A to B or you choose another path from A to C and then C to B. Now one more thing that you can see here, like suppose now we have to go from A to B. Clear? From A to A in path A is converted directly into B, and suppose the heat evolved in this step is Q. On the other hand, when the path 2 is followed, means you are first going from A to C. From A to C, the heat change or the heat evolved or absorbed is suppose Q1, and C to B, the heat evolved or absorbed is suppose Q2. Then the total heat evolved in the path 1 to 2 from like means A to B, it will be Q. That is Q is equivalent to Q1 plus Q2. Clear? Means if you are going from A to B and there is the enthalpy change is delta H, and then you are going from A to C and then C to B, and A to C the enthalpy change is delta H1, C to B enthalpy change is delta H2. When you will add both the reactions, this will get cancelled out and you can see A to B the enthalpy change, because when we are adding both the reactions we need to add the enthalpies also. So delta H will be H1 plus H2. So this was the Hess law. We can see one example also for to prove this. Suppose the formation, not suppose, it is uh, the formation of carbon dioxide we can see here. Carbon plus oxygen when react, they produce carbon dioxide gas. And delta HR means the reaction enthalpy in this case is 300 minus 393.5 kilojoule. Minus sign indicates here that the reaction is exothermic, means energy is releasing in this process. Now suppose we are choosing another path. We are going from another path, path 2. What is path 2? In path 2, first the carbon is reacting with oxygen with insufficient amount of oxygen, and we know that when there is insufficient amount of oxygen, carbon monoxide gas will produce, and in that case the reaction enthalpy is minus 110.5. And then again this carbon monoxide will react with oxygen and it will produce carbon dioxide. Now in this case the reaction enthalpy or the change in enthalpy is minus 283.0 kilojoule. So if we add both these reactions, what will happen? Carbon is a reactant, half plus half, it will become O2. Clear? Carbon monoxide will get cancelled out with carbon monoxide and the product is carbon dioxide. Now we will add both these enthalpies also, and what we are getting here, minus 393.5 kilojoule, which was the enthalpy of the reaction, which was a reaction enthalpy or enthalpy change or the reaction of formation of carbon dioxide also. So it proves that yes, the thermochemical equations can be added, subtracted or multiplied like algebraic expressions to obtain the desired equation. Clear? So this diagram is actually the illustration of Hess law. We have to reach here from carbon to carbon dioxide. So whether we come directly, whether we choose this path or we choose this path, the change in enthalpy will remain same. Clear? So this was the law. On the basis of